Hello, lovely people. Yeah, go on. Lovely people. Hello, how you doing? I hope you're fine. I hope you're well. Here I am during the holidays, and instead of reading, writing, watching movies, or playing with my children, I'm here thinking about you, recording videos for you. I hope you appreciate this. From the heart of my bottom, from me to you. Thank you. So, we're starting a new chapter. It's chapter 8 in the book. And we're going to start solving inequalities. I'm going to keep it exceptionally simple for now. We're going to start really easy, covering the very basics. And as usual, as you know, we'll make it more and more complicated as we go along. But let's start easy, because why not? Let's enjoy it. Yeah, let's do something we can all do. Take some time to relax, do a bit of maths to clear the mind. Yes, and make ourselves feel a little bit better. So, let's just cover the very basics. It'd be nice if you took notes here, if you had this nice and neat in your books, and you sort of got to understand what we're doing. So, X and that symbol there, 2, what does that mean? Think about it. Go. Right. That symbol there means strictly greater than, or greater than. So that means that X is strictly greater than 2. Now, what value is it then, greater than 2? Well, it is any value so long as it is greater than 2. And it could be 3, it could be 4, it could be 39, it could be 1,024, or it could be 2.5. Okay, so it's any value that is strictly greater than 2. That's what it means. A, that symbol, minus 2. What does that mean? Well, that means strictly less than. So A is strictly less than minus 2. Now, what value could it be? Think about it. Give me a value that could be strictly less than minus 2. Well, it could be minus 3, it could be minus 4, it could be minus 100, it could be minus 39, it could be minus 2.1. All those values are strictly less than minus 2. That symbol there, which is very similar to the one we had above, but it's got an extra line underneath. So that means that B is greater than or equal to, so that symbol means greater than or equal to, so it could be equal to minus 10. B is going to be any value so long as it is greater than or equal to minus 10. So what value could it be? Well, it could be minus 9, because minus 9 is bigger than minus 10. It could be minus 3, it could be 1, it could be 29, it could be minus 10. It could be minus 10, because I'm allowed to be equal to minus 10. So, from minus 10 all the way up to infinity, any number there. And that symbol there, similarly to this one and that one, means less than or equal to. So D is less than or equal to 8. Any number, any value, so long as it's equal to or less than 8. So it could be 8, it could be 7, could be 6, could be 5, 4, 3, minus 21, minus 349. It could be 7.3. It could be minus 2.1. So any value that is less than or equal to 8. That's just the basics, what the symbols mean. Now, here, a little bit more complicated. Move this a little bit here. Okay, cool. Now, you may have, we call these two-sided inequalities, because we've got an inequality on either side of the variable there. So how do I read these? In plain English, what does that mean? As you know, we read left to right, so 3 is strictly less than x, which is strictly less than 5. There you go. So 3 less than x, which is less than 5. Now, that means that x could be any value between 3 and 5. 3.1, 3.2, 3.3, 3.7, 4, 4.1, 4.2, 4.5, 4.9. Could it be 5? No, it couldn't be 5. Could it be 3? No, it couldn't be. So it could be any value between 3 and 5. Now, sometimes you may be asked to provide something called What am I writing with this pen that is actually running out? Not what I wanted to do. Okay. Sometimes you may be asked to provide what is called the integer solutions. So provide the integer solutions to that inequality there. And you have to remember, what was an integer number? Think about it, come on. An integer number was a number without decimals, just a whole number. So what would be the integer solutions to this inequality? Well, we know x could be any number between 3 and 5, but because it has to be an integer, it cannot have a decimal. So in this case, the only possible answer is 4. That's right. Okay, sorted. What about here? What does this mean in plain English? That means that minus 2 is less than or equal to a, which is less than or equal to 3. So it could be any value between minus 2 and 3. However, again, if they ask me to provide the integer solutions, I would say integer was number without decimals. So what values could a be between minus 2 and 3 that have got no decimals? Could it be minus 2? Yes, it could. It could be minus 2 because I am allowed to be minus 2 because it's less than or equal to minus 2. And then it could be minus 1, it could be 0, it could be 1, it could be 2, could it be 3? It could be 3. Could it be anything else? No. So those would be the integer solutions to that inequality there. Alright, I've got one more inequality here. It says that minus 1 is less than x plus 4, which is less than or equal to 7. Now I've got that plus 4 there. And before I solve that, before I can find the solutions, I need to get rid of that plus 4. So think about these as like an equation, How did we get rid of that plus 4 when we were solving a normal equation? What did we do to get rid of the plus 4? We took away 4. You always do the opposite. Now here, what we're going to do is take away 4 from all 3 sides of the inequality, okay? Instead of only having 2 sides to an equation, I've got 3 sides to the inequality. So I'm going to take 4 away from all 3 sides. So minus 1 take away 4, careful, is minus 5, less than x plus 4 minus 4 is just x, and then I've got less than or equal to, and 7 take away 4 is 3. So I will do that first, and now I can think about what are the integer solutions to this inequality here. Can it be minus 5? No, it can't, because it is strictly, x is strictly greater than minus 5, or minus 5 is strictly less than x, so it couldn't be minus 5, but could it be minus 4? It could be minus 4. Could it be minus 3? Yeah. Minus 2, minus 1, 0, 1, 2. Can it be 3? It can be 3. So there you go. And before you ask me, sir, do I have to write all those answers in the answer? Yes, you do, all of them. Because if they ask you for the integer solutions, you have to provide all the possible answers. This is the main difference between an inequality and an equation. How many solutions did we have in an equation? 1. Here we got a whole range of possible solutions, okay? Good. And then let's do the last example here before you start working. 6 is less than or equal to 2x, which is less than or equal to 20. But I got 2x there. I should only have an x, 1x. I got 2x. How do I get rid of that 2? Divide everything by 2. All 3 sides of the inequality we are going to divide by 2. So 6 divided by 2 is 3, less than or equal to 2x divided by 2 is just 1x, less than or equal to 20 divided by 2, 10. So now 3 is less than or equal to x, which is less than or equal to 10. And if the question asks find all the integer solutions to this inequality here. Well, think about it. I'm going to give you 5 seconds. 3, 2, 1. All the possible integer solutions that you have to write, yeah, all of them. Remember, you have to write all the possible solutions are 3, 4, 5, 6, 7, 8, 9, and 10. And that's my introduction to solving inequalities. I hope you found it helpful. Please let me know if you need anything. Get in touch. As I said, make sure that you've copied the examples out in your book, okay, and you take notes. Some of you do a lovely work of it. Some of you, not at all. You don't solve them like I show you. You don't do what I tell you, and then you get confused, okay? Girls, you tend to be quite good at taking good notes and good examples. Boys, you're breaking my heart.